Today we'll discuss Python variables. Variables are one of the essential building constructs of every language and every programming language. So first of all, we'll discuss the formal definition of variable. A variable is something that can change. It is also clear from its name that variable means to vary. The value of a variable will change or can change during the execution of a program. And if the value will not change, it is fixed, then we refer to it as a constant. A variable is a way to referring memory locations used by a computer program. A variable is a symbolic name for physical location in memory. Let me explain you. Whenever we use a variable, let's suppose in C language, when we write int C, then a memory location, let's suppose this is RAM inside the system, then a location of 2 bytes in memory will be allocated to the variable C, and this location will be called as C. And when we assign certain value to C, either by assignment or through input, if we give C is equal to 10, then value at that location will be 10. This location name is C and the value is 10. Okay, since integer is of 2 bytes, so 2 bytes space will be given in the RAM, and that location will be called C, and its value will be given as 10. And later on in the program, if the value of C changes, let's suppose we add C with D, and D is having value 20, then 10 plus 20, C will become 30. So this value will be changed. So 10 will be overwritten by 30. So the new value of C will be 30 now. So we have learned two concepts here. Whenever we use a variable, a certain memory location is allocated to that variable with the name of the location as that variable name, and the value of variable changes during the execution of the program. You need to remember these two things. But unlike C, C++, Java, we don't need to declare variable before using in Python program. As we have learned in C language or in Java or C++, first of all, we need to write int A, int B like this, or float A, B, C, float X, let's suppose. But in Python, you just write the variable name A, 10, then that variable exists. You don't need to mention the data types. Whatever value we assign to the variable, it becomes that data type. If I give a float value, let's suppose if I give A is equal to 5.5, then this will become a floating point variable. And if I give a string value, let's suppose I give the value XYZ, then A will contain a string value. That means it will become a string object. Here it is floating point, and here it is integer type. We don't need to declare int, float, char, etc. at the beginning of the program. We can use variable names anywhere in the program whenever we require it. Let's go through the text once, which is very important. Memory location contains values like numbers, text, etc. The variable is used to tell the computer to save some data in locations in memory or to fetch the data from that memory location. One of the major differences between Python and other languages such as C, C++, and Java is that they deal with the data type. In a strongly typed language, every variable must have a unique data type. For instance, if a variable is integer, only integer values can be saved in that variable during the execution of the program. I already told you, if I declared a variable A as integer, then I can assign only integer value to this variable. I cannot assign floating point value later on in the program. Okay, but in Python language, we can change their value and we don't need to declare it again and again. Therefore, a variable is a location in memory used to store certain data, that is a value. Variables are given unique names. Sorry. Variables are given unique names to differentiate between different memory locations. And you must remember that the rules for naming the variables are same as we have studied for identifiers. Like the first name cannot be a digit, like I cannot write this as a variable name. First name cannot be a digit. We cannot use special symbols in variable names, or we cannot use comma, etc. I cannot give white spaces in variable names. Let's suppose if I give total marks as a variable name, then I need to put here underscore to connect it rather than giving white space over there. So all the identifier rules are applicable on variable names that we have studied in previous lectures. Now I will show you how to use a variable. Here we have use a variable a and assign value 10 to it. A is equal to 10. This is integer variable. B is equal to 34.87. This is a floating point variable. And C is equal to programming. This is a string variable. So all these variables are just declared and values are assigned. We didn't mention their data types, and they are declared in Python prompt. As well as you can use them in the script mode also in the similar manner. The assignment operator is used to assign values to a variable. Any type of value can be assigned to a valid variable. Let's see another example. Here we can see that here I have given a is equal to 24, which is integer variable, and then I have given a is equal to hello. That means now I have assigned a string value to the same variable a. So the value of a will be changed. But in C or C++, if I have declared a as integer, then only integer values will be assigned to it. So in Python, variables are quite flexible and easy to use. Next is multiple assignments. We can assign single value to all variables in one statement. Suppose I have three variables A, B, and C, and I want to assign value 1 to them. That can be done in a single line statement in one go. A is equal to B is equal to C is equal to 1. Then all of the variables will carry the same value 1. Here all three variables are assigned to same memory location when an integer object is created with value 1. Multiple objects can also be assigned to multiple variables as shown below. Here integer value is assigned to all the variables. Suppose if I want to assign different data typed values to different variables, that can also be done. A, B, C is equal to 10, 3.5 and jack. Then these values will be assigned in respective order. Here A will be assigned 10 internally, B as 3.5 and C as jack. It's an integer number, this is float and this is a string. With just one assignment operator, I can assign value to them by separating them with commas. In the above statement, an integer object with value 10 and a float object with value 3.5 are assigned to variable A and B respectively. The string object jack is assigned to third variable C. So this is about variables and how we can assign values to them in a single line statement we have learned in this topic. Next is understanding data types. Although we don't use data type name while declaring a variable int, float, cap, we use them directly. A is equal to 10 or C is equal to jack directly in Python. But that doesn't mean data type don't exist in Python. They exist. There are various kinds of data types in Python which are given as follows: number, string, list, tuple, set, dictionary, and file. There are 7 inbuilt data types which exist in Python, and all of them are very important. Number, in order to handle all kinds of numeric data, there is a data type number. We don't need to mention number or declare number anywhere, but internally it handles integer, float, double, all those kinds of number. We don't need to mention double or float or anything because it's very simple in Python. Just you need to write the variable name and assign value, either floating point or integer value or large float value, which comes under double in C or C++. So all numeric data which is used to perform mathematical operations comes under number data type. That means all integer, float, double data types come under number data type. Next is string. If I want to input textual data or I want to use textual data in my program, then string data type is used. Internally, it's a string data type. str is used for this. Then I can give only textual, that means alphabetical data or alphanumeric data under this data type. The next one is list. There are certain sequential data types available in Python, which are list, tuple, set, dictionary, etc. List is something like arrays that we study in C, but arrays are homogeneous data type. List is heterogeneous. It's a sequential data type. It represents sequential data that the programmer wishes to sort, merge, etc. All the operations that we can perform in a list can be done by using list data type. However, it can contain heterogeneous kinds of data. Next is tuple. It represents sequential data with a little difference from list. We'll study the difference in the subsequent chapter in detail about the difference between list and tuple. Next is set. We have studied about mathematical sets such as A, B, C. This is one set, and there is another set, X, Y, Z. We can perform operations like A union B, A intersection B, A complement, B complement. Fine. You have studied such kind of operations in mathematics, and for that, we need to declare or create sets like this. But Python provides this data type as inbuilt data type. It is used for performing set operations such as intersection, difference, etc. with multiple values. So all the mathematical operations that we perform on sets can be implemented by using the set data type. Next is dictionary. It represents a collection of data that associate a unique key with each value. Dictionary, you might have studied in data structure as well. Dictionary contains two attributes. One is key and another is its corresponding value. This is basically used to fetch data from files for hash functions, etc. So this is also readily available in Python for using or fetching data from files. It represents a collection of data that associate a unique key with each value. We'll study this data type also in the next chapter, native data types, in detail. Next is file. File is a permanent storage. In order to save the data permanently on the hard disk or any storage device, we need to use the data type file. File can be in the form of document file, text file, or graphic file, any kind of file. File represents data that can be stored permanently as a document in a computer. And for that purpose, we use the data type file. All these data types will be discussed in detail in the chapter native data types with various methods, operations on them. We study them in detail in the chapter native data types. But before that, you must know that there are conversion functions through which we can convert from one data type to another. Suppose I want to convert from float to integer, then I will write int n base, converts n to an integer. Base specifies the base if n is a string. Suppose if n is a string, then we need to specify the base. If I specify 10, that means it will be converted to a decimal number, integer number. Similarly, long data type, we can also convert that number to a long data type, float data type, complex data type also exists under number data type in Python. Then there are other data types, functions. The name of the data type is the function name in which we want to convert it. If I want to convert a number from float to integer, suppose I have a number a 5.5, I will just write int a. Then 5.5 will be converted into int and I will be returned with the value 5 only. Okay, and in case if a is having value 5.5, that means this is an integer value and I want to convert it into float, I will just write float a and I will be returned with the value 5.0. That means now it has been converted into float. Similarly, I can also convert a number into a complex number as well, complex, real, comma, imaginary. Suppose I have two variables of integer type, a is 5, b is 6, and if I write complex 5 comma 6, then these two integer numbers combined will work or can be used as complex number this. And furthermore, I'll assign this value to another variable. Let's suppose c, then c will contain a complex number 5 plus 6i. It will be like this, where 5 is the real part and 6 is the imaginary part of the complex number. This is how we can perform conversions from one form of data type to another. So there are various kinds of data types are given. You can go through this table for converting one data type to another. This is for string conversion, tuple to list or list to tuple, set conversion, dictionary, frozen set, etc. Once you will go through that chapter, then it will be easy for you to understand these data types and how to typecast them from one data type to another. It's very easy and they can be used very easily in the programs as well.